Alright, this video is going to cover development and hello world. So we're going to redo our first Python program. So this is chapters 1.9 through 1.13 in the Talking Through Code textbook. Alright, so we're going to do a little bit of content first, and then we'll look at our PyCharm and code. So we have to talk about the development cycle. How do we go from an idea to actually writing a piece of code? So the first step is to design the program, and this involves gathering the requirements, figuring out what it is we need to do, and then how we're going to execute it for our program. So design the program from the beginning, right? We want to plan before we ever touch code. Then we're going to write the code, and this is the first iteration of the code, right? We're going to write it, we're going to develop it incrementally as we go. We want to make sure that as we work, we create a program that's going to actually do what we want. So once we've written the code, we're going to correct any syntax errors. And this correcting of syntax errors, it happens sort of while the code is being written, right? It is a part of the process, right? But even no matter how skilled or practiced you become, you can still introduce syntax errors, right? And these are errors that are structurally wrong with your code that will need to be fixed before your code will even run. Once you've done that and you have a program that can run, you're going to test the program, right? We need to make sure that it does work, which is why the designing part is so important, right? We have to know, what does it mean for our program to work before we can effectively test it. Then you're going to correct any logic errors, right? Anything that's wrong with your code. Any runtime errors, any semantic errors that you find, you're going to correct those as your step, and then you're going to go back to testing. So these lines look pretty linear on this flow, but you actually sort of go between the pieces several times in the process, right? You might write a little bit of code, correct syntax errors, test that little bit of code, correct logic errors for that piece of your program, and then go back to writing code. So there could be a lot of other little arrows showing cycles here. Then once you correct your logic errors and your program works, whatever that means for that iteration of your code, you go back to the beginning to design the program, right? Everything we do in programming is iterative. Our code, especially when you're a software engineer, doesn't stay the same forever, right? It is constantly getting updated and made better, changed as technology changes. So these are the 5 steps, and like I said, we go between them all pretty fluidly as we're working with our code. So there are 2 types of languages. There's natural and then there's formal. A natural language is like English, Spanish, languages that we speak aloud. And then formal languages are languages like the notation used in calculus or chemistry or a computer program, right? So Python is an example of a formal language. It's one that's been created to serve a specific purpose. So natural languages are sort of ambiguous, right? We see this a lot whenever we have non-native speakers, right? You've learned a second language and you're trying to use it, and you say something that's not quite the way a native speaker would say it. And so it becomes ambiguous. There are multiple ways that it could be taken, right? In natural language, there are multiple ways to say the same thing. Sometimes there's a possibility for miscommunication with natural languages. Formal languages, however, are unambiguous. There is not more than one way to interpret a print statement in Python. There is one correct way that it works, and so there is no miscommunication between us and the computer, because the computer just does exactly what we tell it to do, because there's no ambiguity. That doesn't mean that it does what we expect it to do, but it does do exactly what we tell it to do. Natural languages can be redundant, right? And this goes along with the ambiguity a little bit. There's multiple ways to say the same thing, and so we can be redundant, keep saying the same thing in different ways. Formal languages, though, are concise. And that's not to say that formal languages can't be redundant sometimes, but good, correct usages of formal languages are concise. They tell what they mean, and they say it in the most conservative way possible, right? Using the most precise information they can. Natural languages are non-literal, right? We have metaphors and similes and analogies and all these things, this non-literal language that can inform what we're talking about, but again, it leads to ambiguity here, right? What does it mean to say that debugging is like being a detective, right? That's a non-literal statement, and it could be hard for somebody to understand if they are not if they don't have the context. Formal languages, though, are extremely literal. There's no figurative language in Python, right? It is purely, this is what I am saying in the code, and this is exactly what I mean, right? There's no ambiguity. You can tell exactly what's supposed to be doing. So natural languages are spoken, English, Spanish, all of those, and formal languages are used for a specific purpose and they are written. So this is calculus, chemistry notation, any programming language like Python, they are very specific, and that was what allows us to write programs that work in the same way every time, regardless of who wrote them. All right, so as we are in the development process, that first step is designing the program, and sometimes people use program diagrams to do this designing. So these are diagrams that are language agnostic, meaning you can use them for any language, and they have different shapes that mean different things in the diagram. So the first one is an oval. These are called terminal symbols. They appear at the start and the end of our program. So this oval at the top is start, and then we're going to have some arrows that follow the flow of execution through our program. So there's this arrow into this input, and input is shown as this parallelogram. So this input is coming in from the user, and we're going to be able to use it in our program. This rectangle is a process or a task. So this is, adding to a variable, doing some sort of math. Anything in the code that does not produce output is considered a process or a task. Then we have output. So input and output are both parallelograms. So you have to, when you're creating these diagrams, make sure you notate it really clearly, whether you're taking an input or giving back output. And then the end is another oval, right? Another terminal symbol. So we start with an oval and end with an oval every time, and the arrows in between are showing the flow of execution. How are we going through our program? So looking at this diagram, we could take it and immediately turn it into code if it was a little bit more specific, if we knew what kind of input we were getting and what kind of output we were expected to be giving. So again, you draw these to get ready to write your program. And there's one other symbol, which is a diamond, which we'll see whenever we get to conditional statements. All right, so we're going to go ahead and open PyCharm again with the goal of making a Hello World program again, right? We did this in the first video for chapter 1. We're going to redo it here. So I've opened PyCharm, and I've used this Talking Through Code chapter 1 project before, so I'm just going to go ahead and open it. And on the left here, I'm going to right-click and do New Python File. So what I did is I right-clicked, New Python File. Right. So I'm going to do Hello World. And remember, whenever creating these new files, we don't have to include .py because it already knows it's a Python file. All right, so this is going to be our first program. So with these first programs, we're not going to include things like a main function yet. That's going to come later. So worlds, the celebration emoji. Okay, there we go. So this is Hello World with a celebration emoji, and it is going to print the words hello world to our console, and that's it, right? This is pretty much everybody's first program in any language, is to be able to output the words hello world. So now we have to talk about one last thing, which is comments, right? Comments go into our code, and they don't affect the output. They are just essentially ignored by the interpreter, but they're there to give more context to our code so we can understand it when we come back 6 months later and are trying to figure out what we were thinking at various parts of our code. So there's a single line comment, which starts with a hashtag, right? So that's a single line comment, and it happens all on its own line. If I want to put a comment on a specific line of code, and I don't want to do it above, I can do an inline comment, which is a comment at the end of a line with another hashtag. So it's a single line comment that goes in the same line as code. If I want to have a multi-line comment, I do it with 3 sets of quotes. Those can be either 3 sets of double quotes or 3 sets of single quotes. It doesn't matter which one. But those are the 3 types of comments we can have. We can have a single line comment, we can have an inline comment, or we can have a multi-line comment. And whenever we run the code, we still have the same output from before. It did not affect the output of our code. They are just there for the programmer to get more explanation, description, context for the code that they've just written. And whenever you're deciding whether or not to leave a comment, think to yourself, is this line of code a logical chunk that could need explaining? We want to try to make our code as self-documenting as possible, which means good variable names, clean structures to need as few comments as possible, right? We are not in the habit of writing accidentally or on purpose obfuscated code. But we will need comments, right? There will still be things that deserve explanation, particularly the functions themselves, which we'll talk about whenever we get to functions in a later video. All right, and that's it. The next video is going to be about values and data types, and that is chapter 2.1.